Hello, welcome back. I am today going to be talking about Viterbi, which is a very important algorithm, right? Used in many applications, and I'm going to be spending some time so that you get a feel for what it does. Once you might have seen it in other places, but it's good to always refresh it and get an understanding of what it's trying to do. And as I said, it's a game changer for things like speech and so on. Okay, and the same idea, variation of that is the forward backward algorithm. I'll talk about it also. And then there is in today's deep learning methods, there is something called connectionist temporal classification, or CTC, and they are also, deep learning methods are used for sequence to sequence modeling, and there also this concept of Viterbi / forward backward is going to come into picture, right? And therefore it's good that you have a feel for what it's trying to do. Okay, so the basic idea, if you remember, we talked about states and so on. So I'll just remind you a little bit about what we did last class. So we had this concept of states, which is sunny or cloudy or rainy and so on, and we were observing weather conditions, on different days, right? T3, T4 and T5. So day 1, day 2, day 3 something, right? So normally we, just to make it more generic, we call it state 1, state 2, state 3, and time instant 1, 2, 3, T5, like that, T10, T100, whatever you want. Okay, so along this direction is usually what we call as a time, evolution along time, and these are the different states, right? So different states that we are modeling, right? So these are the events that occur one after the other, right? And so it can be the weather like sunny, rainy, cloudy. As we'll see later, these states in speech can be the sounds, different sounds, e, u, and so on, right? How are they occurring in the time, and so on. So in some other like DNA sequences, it could be the different acids or different proteins that can occur, and so on, so on. Okay, so and what we are looking for is that at each so we want to look at prediction or probabilities for different paths. So we have this concept of what's called transition probability, right? Transition probability, right? And so if I have state 1, state 2, state 3, and we are talking about, let's say, the first order process, right? First order Markovian. Right. So we are talking about transition probabilities. So these are the 3 states. So we are saying what is the probability? It's a first order process. So given that I'm in a particular state S1, how probable is it I'll go back to state S1? Or given I'm in S1, how probable is it to go to S2? So these all have to add up to 1. So this is 0.55. So this has to be 0.45, right? Yeah, something like that, right? So this all this total probability should always be 1, right? Given the state, I can only be in these 3 states, right? So the often what we are interested is what is the probability of observing something like S1, S3, S3, S2, S1, S1, S2, S3, like that, right? So this what is this probability of such a sequence occurring, right? So probability of the sequence we are interested, right? And that means that we are looking at the first order Markovian process. So we start somewhere. So start from, let us say, the starting state was S2. So this becomes probability of S1 given that it was S2. Then this guy will be probability of S3 given S1, right? Then this guy will be probability of S3 given S3. Then this guy will be probability of S2 given S3. That's the way we are going to compute. And all of these probabilities, which we call as AIJs, right? AIJ, these are the transition probabilities AIJ. This is all captured from this table. That's how we are going to get, right? The problem is, if I have n states and capital T units, I will have n into n into n capital T times, which is n raised to the power of t different sequences, and therefore n raised to the power of t different path calculations. So, for each one of them I will get one total probability, right. If I change the sequence, I will get another probability. So, I will get n raised to the power of t different probabilities, and if you compute brute force, right, let us say n equals 3000 and t equals 500, right. This is 3000 raised to the power of 500, and that is not feasible, computationally not feasible. This is just in speech, this will be only one utterance, 5 second. I've already spoken to you maybe for almost 12 to 15 hours now, right, 12 hours at least, right. And even to do that 5 second part, what I spoke just now, last one sentence or two sentence, that itself, you cannot computationally do it, right. And that is where Viterbi is an efficient way of doing it, okay. Efficiently does this, okay. So, what is the basic idea of Viterbi, right? So, what is the basic idea of Viterbi? The basic idea of Viterbi is very simple, that if you give me that, let's say that I have so many things, T1, T2, T3, T4, some Tjth state, and then T capital M, the last state is there, and let's say I have S1 state, S2 state, S1 is there, S2 is there, S3 is there, right, S4, okay, and so on, okay. What it's trying to say is that if at this particular point, let's say I am here, S3, at the jth time instant. So, what does this mean? So, we are going to call, gamma j3. So, what this means is I try to find gamma 3j. This is the third state at time tj, or the jth time instant, the best probability that I can have. The best probability okay. So, to do that, what does it mean? It means that I could have come, right, I could have come here, right. So, S1, one path is S1, then S1, S4 like this, like this, like this, and I could have come here, that is one path, or I could have come here, right. So, another path I could have taken is come here, S2, then go back here, S3, then come back here, S4, and then come here. This is another possible path that I could have taken, right. And another path could be that I started here, then I went here, then I went, so another path could be that I went here, then I went here, then I went here, then I went here. So, there are so many paths I can take, okay. And all of this, how do I find the probability? So, there will be, each path will give me one probability to come here, right. So, I compute the probability for each one of them and find the one that gives me the maximum probability. So, there is only one path. I mean, we are assuming that all paths, have slightly different probabilities. One best path we are looking for. So, that best path will give me the highest probability of being in the third state at the jth. So, let us say I have solved this problem, right. If I have solved this problem, the idea of Viterbi comes down. Now, if I have solved this problem, let me look at the tj plus 1th point, right? So, tj plus 1th guy, right? So, I am now, if I have reached here, this is the best I am saying, right? This is the best that I can do, right? Now, if I am looking at this particular guy, right? Now, this will be what? Gamma, but remember the subscript is the first state, but now the j plus 1th time instant, right? Now, I know what is the best path that I can come here, right? From here, if I am going here, there is going to be a 3, 1, right? There is a probability or transition from the third state to the first state. So, this guy is actually equal to what? Gamma 3j multiplied by a11, right? Right. So, the maximum probability to reach here is gamma 3j. If I want to reach from here to here, I will get multiplication of a, sorry, this should be 3, 1. I have not written properly. This should be gamma 3j multiplied by this guy, 3 times 1. Similarly, I could have found by another, the other path, this will be gamma 1 being in the jth state. So, this gamma tells me what is the maximum probability to be in the first state in the jth time instant, right. So, if I want to go here from here to here, this probability will be what? Gamma 1 times j, and this is a11 itself multiplied by a11, right. So, I have to, now if I want to compare these two parts, I have to look at, if I want to find the highest probability, I should look at, is this larger than this, whichever is the larger, I should choose that, right. But there are other guys also. So, I can come from the fourth state, right. So, I can come from gamma 4 times j, that will be a 4 1. So, there it will be gamma 4j multiplied by a 4 1. So, now I have to compare all of these three things and find the max, right. So, even though this can be larger than this value, right, but if this transition probability is higher than this transition probability because of this multiplication, it is the product that I should look and see which is higher, right. Then I do this, and among all of this I find the one that is the best path. So, if among all this if I find it, I can find that probably this guy gives me the best highest probability. This is the max highest probability. Then I know that to come here, the best way I could have got the maximum probability is to first come here, and how I came here is already captured. The history is already captured, and only thing I have to worry about is compare this guy with A41, then compare A31 with this guy, or compare the gamma 1j with this guy. And so, all the previous maximas I am going to look at, multiply only with the transition probabilities and look for one more maxima. So, what happened historically is all captured in these gammas, right. These gammas are already captured the history, and to go to the next level I need only few calculations, that is the multiplication with the individual transition probabilities. Similarly, when I come here to go to j plus 2, right, j plus 2 is even more trivial. Again, I have to look at this path and look at all the max that are coming here and only multiply by a, that corresponding guy, and not even worry about all the other history. So, at every j plus 1 and j plus 2, I only look at the maxes at the previous time instant and multiply with the transition probabilities. This enormously saves time. Okay. Why? Because there is lot of common paths between this guy and this guy, and if I do the brute force, I am actually multiplying again and again some of these common paths. For example, if you look at this guy, you can see the blue guy is almost same except for one path that is different. Okay. All the other paths are similar, right. So, we are actually wasting by calculating all this common paths twice, right. There is red arrows also coming, the blue arrows are coming. If you do the brute force, we keep repeating, doing the same multiplication again and again and again unnecessarily, right. So, we capture all that information in that gamma 3j, and therefore Viterbi is very, very efficient. So that is the basic idea. So if you understand this properly, then I will go back and use the slides themselves. Okay. So the basic idea of Viterbi is just this, that at this time instant gamma, first state and third time instant, I only look for max from the previous guys. So gamma 1, 2. So gamma 1, 2 coming to the state is only A11. So gamma 1, 2. This gamma 1, 2 captures what? What is the maximum probability to be in state 1 at time instant 2? I have already found out the best probability that I can be. Now I am multiplying by A11. Similarly, gamma 2, 2 says what is the best probability that I can have to be in state 2 at time instant 2. Then to come here I need to A21. That is what I am doing here, A21. Similarly, gamma 3, 2 says what is the best probability that I can have to be in third state at time instant T2. Then I can come here only through A31, this path. So, A31. Now, what is the best probability that I can have here? It can be only, I know the best probability here multiplied by A11, I know the best probability here multiplied by A21, I know the best probability here multiplied by A31. Now, after multiplication, the order can be slightly different. One of them will be max, right? I put that max here, right? And that tells me, given all from here to here, from here to here, here to here, only one of them paths is going to be the best path, and that is what is going to give me the maximum probability. So, if you look at this calculation here, very simple, right? It's only dependent on the previous gamma, gamma 1, 2, gamma 2, 2 and gamma 3, 2. That's all it has. So, this previous layer, so to speak, is the only number that I have to store, and then I have to store the transition probability. That is where the power of Viterbi comes. So, if you look at this calculation also, gamma 2, 3, it's only going to depend on gamma 1, 2 or gamma 2, 2 or gamma 3, 2 and the transition probabilities. Now, it is because it's in the second state, it will either come from A12 or A22 or A32. With these 6 numbers in this case, of course, if there are more states, more numbers, and then I take the max. This is the power of Viterbi. So, when I am doing this calculation, I need only the gammas at the previous guys and the transition probability. Now, if I want to go to gamma 1, 4, gamma 2, 4, gamma 3, 4, right? So, fourth time instant, again it is only these, the max that I obtained here will come the max. So, now gamma 1, 3, gamma 2, 3, gamma 3, 3 will come into the picture and only the transition probabilities. So, at every point we are only getting the transition probabilities and whatever is the maximum numbers here. Okay, that is the basic idea of Viterbi. So, if you do it, let's do it in a systematic way, so that we find out what is happening. Okay, so let again we have to start somewhere. So, let us assume we will go back to the weather example. Now, already I have the transition properties. These are the AIJs, A11, A12, A13, A21, A22 like that. So, these are the transition probabilities which we have calculated historically by looking at the data for the last 100 years or 10 years or 1 year or something. I am going to say that I am looking at the 3-day forecast or something. So, given today's weather is sunny. So, day 0 is given sunny, right? That is already known. Now, my prediction is what is the T1 next day, T2 2 days after, T3 third day, right? So, from today I have observed 1, 2, 3, 3-day forecast I want. So, I am already told you it is sunny. So, because it is going to go from the initial state sunny, it can go to only starting from the sunny state, it can go to sunny again or cloudy again or rainy again. So, that is fixed 0.5, 0.375. So, to be back in sunny, right, tomorrow's forecast, what is the best that I can get? So, given today is sunny, tomorrow's best forecast that I can get is sunny 0.5, right. So, I can, and this cloudy is 0.35, 375 and rainy is 0.125. So, there are only 3 paths. So, sunny gets only one path because I am starting. Okay. Then we will see that in the subsequent states you will get multiple paths coming. Okay. So, at this point the maximum probability to be in sunny is 0.5, 0.375 and this will add up to 1. Okay. So, now Now comes the interesting part. So this is where the Viterbi comes into picture. Now remember, I'm going to go to state 2, and all that I'm saying is for that I need only these 3 numbers. Okay. So let us look at this. So I already got 0.5, 0.375, 0.5. Now again, from the first state to first state, the probability is 0.5. So this is that A11. From the second state to the first state, the second state to first state is 0.25. From the third state to the first state is this guy to this 0.25. So to be in this first state, this is the subscript first state in the second day. Okay. What do? I take this gamma 11 and multiply by 0.5. So gamma 11 is 0.5 and multiply by the transition probability 0.5. So this is one number I'll calculate. Now I am already 0.375 here. To go from A2 to the first state is 0.25. So 0.375 multiplied by 0.25, that is the next one. Similarly, third state, given that I was already sunny, that only 0.125 I am here, rainy. To come back to the sunny state, right, the state 1 is 0.125 multiplied by 0.25. Now these 3 probabilities, so the probability from here coming to this path, or coming from this state to this path, or coming from this state to this path, among these 3, the maximum one is, we are going to, I mean, this is, I have to look at the max, I have not calculated, we will show it in the next slide, and I will repeat it so that it reinforces what you have understood. So similarly, if I am coming to the second state, right, if at the second day, so what is it, like this is now the how probable, what is the best probability that I will have to be in cloudy state on day 2. I can what? I can come from the sunny state from the previous day, right. So that is already 0.5 multiplied by the transition coming from state 1 to state 2. State 1 to state 2 is 0.375. So that is the 0.375 that I am talking about. So this is 0.5 here multiplied by 0.375, that will come here, or I could have been cloudy the previous day, which has a probability of 0.375, and then I come here, which is 0.125 probability, that is here, or I can be here with a 0.125 probability and then I am coming here, which is a 0.075. So there are 3 probabilities to come here from the previous conditions, or if I am looking at being in the third state at time instant 2, then this is rainy state. So I could come from rainy itself, but rainy at, so I'll start again from sunny, which is 0.5 multiplied by this 0.125, sunny to rainy. Sunny to rainy is 0.125. So 0.5 into 0.125, cloudy to rainy is 0.625, cloudy to rainy is 0.625. So cloudy itself was 0.375 multiplied by 0.625, and rainy to rainy is 0.675, and so that is the thing, right. Now this max that I am doing, I will take only the maximum probability. So you will get one number here, right, the max of the multiplication of this. So if I multiply, this is a max of 0.25, 0.095, 0.03, max of 0.1. So here the max is 0.25. So that is the maximum probability that you will get here. The maximum probability here is 0.1875 and the maximum probability here is 0.2345. So it is the second guy, the guy coming from cloudy, that is highly probable here. Here the sunny guy is highly probable coming from sunny, and here also coming from sunny is highly probable. So this guy says the maximum probability is coming from sunny to sunny again, because that's the highest probability. So this is the best path that you can have, that's the most probable path. This guy is 0.1875, again that is sunny. So that means coming from sunny, the initial condition, to sunny here. So this is the best path. So for the first, being in a sunny condition on day 2, this is the best path. Being in cloudy, the best condition is like this path, and here we see it is cloudy to rainy. So the best path to be in rainy is actually coming from sunny to cloudy to rainy. So this is the best path, okay, and that's what you are finding out here. So it is saying that so this is represented by the what is the best path is given by the green. I should choose that path. So starting from Sunny, you go to Sunny and come to Sunny. That is the best probability you can have when you come here. The green path is the best path. The red are not desirable. They have lower probabilities. Similarly, similarly, Sunny to Sunny to cloudy is the best path that you can come. So coming from the sunny state is the best path. Coming here from previous sunny state is the best path. If I want to come here rainy, this is rainy, remember, it's best to come from the previous being cloudy. So sunny, cloudy, rainy is the best. Okay. Now, if I want to do the third day, right? Now, the third day you will see only depends on these numbers 0.25, 0.1875, 0.235. All these calculations are now captured here. That is the power of the Viterbi algorithm. So if you can keep in mind, we will see only 0.25 will come into picture here, 0.175 will come into picture here, and 0.2345 will come into picture here, and then of course the transition probabilities. Okay. So again, the best that I could have is 0.25. To come here has to be multiplied by 0.5. That's what they are capturing here. The best that I can have is 0.1875, and I multiply by the transition 0.25. So that is coming here, and so on. So again, I have to find the max of this. Similarly, when I am doing here, if I am coming from Sunny, it's multiplied by 0.25 times this probability 0.375. And sorry, again I touched the monitor, so it goes off. Okay. And so on. So if I am doing this guy and I want to come from here, this is the last that I'm calculating. So I'm already at 0.235. I have to multiply by 0.675 to come here. That's the last calculation I'm doing. So I have to do for each one of them only three calculations. These guys and the transition that I can come to that state, right? So Viterbi is reducing the number of computations dramatically. Okay. And if I do that, now you can see it's suggesting that if I want to be in Sunny, if this has to be Sunny in the third day, it is following the same path. The previous was also Sunny because that's the maximum. Looks the first guy's maximum. So Sunny, 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 Sunny. In the way that the transition probability has been figured out, this is the best path that it can take. If I want to be here cloudy, among all of these, which is the most, this is the most 0.023, right? So the second one is the most probable. So coming from cloudy is probable, and cloudy itself, you saw the green path came from Sunny. So here it will be till here I have to come from Sunny, 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 cloudy, and then it says come to cloudy itself here. Okay, that's what is the maximum here. The third one, this path is the best path. So it says coming from rainy is always going to be the best path. So this path should be green. Coming from rainy should be the best path. So this should be green. This is the path I should desire. So it is going to be this path, this rainy, and this rainy itself came from cloudy, and that cloudy itself came from sunny. Okay. So this is saying it should come from rainy, this should come from sunny, and this also should come from sunny. Okay. So essentially this is what is the Viterbi algorithm. Okay. And then I will choose among all these paths whichever is the maximum and retrace my so what is the best path. So now I'm trying to find the best weather condition given the transition matrix and the initial guy being sunny. So we see among these three probabilities, this is the best probability. So I have to retrace my path. So its last day will be sunny, then it will be cloudy, the second last day will be cloudy, and the third last day will be again or the first day will be cloudy. So the green path is this. So given sunny, this is actually the best path or the best sequence that you can get, and this is done simply by carrying the multiplication step by step in a forward manner, where each layer we compute, or each we compute forward the max probability up to that point and then carry forward. Okay. So this saves a lot of compute effort, right? And this is what we call as a Viterbi algorithm. Okay. And so this should give you the same answer as the brute force, but you should implement this on a computer, right? This algorithm, see, it's very simple, right? I mean, just max and a product. That's all you have to do. 2 operations in an iterative loop is all that you have to put, okay, depending on the number of timestamps, okay, and the number of states obviously matter. If you look at this answer, this should exactly reflect what we got in the brute force method. So, this is called the backtracking in Viterbi algorithms to find the sequence that best explains the data or the maximum probability. So, point 3, all the green ones. So it will be this one. So, and so this is the cloudy, rainy. So, this is the correct sequence. Okay. So, just let me go back. So, this answer was cloudy, rainy, and you can double check this. The same answer you would have got done by the brute force way. So, 0.15, and this was cloudy, rainy. This was the best solution. This brute force way, I could do it because it was only 3 days and 3 weather conditions. As I said, in speech, we don't do this often. Okay, we can't do it also in practice. Without the Viterbi, it's impossible to even achieve the answer. But since we are doing it in speech, you know that this method must be very, very efficient, right? And that's why in a few milliseconds probably we are able to get the answer, which would have taken even supercomputers like billions of years or something. Okay, so it's all simply just understanding how to do it, whether we are repeating unnecessarily doing calculations by brute force. Okay,